1978, two spacecraft were launched from Earth in opposite directions. They were meant to go to deep space and be our eyes where we can't physically get to. One of the spacecraft, the Voyager 2, is no more than 11 billion miles away from Earth, and diligent engineers and technicians kept in contact and maintained it. However, even in space, disruption in service happens, and this caused the Voyager 2 to be completely cut off from Earth for more than a whole year. The first time in more than 4 decades, the spacecraft has been roaming the universe that it would completely be on its own. How did Voyager 2 manage on its own, and how did NASA manage to connect back to the spacecraft? We bring you the story of how NASA finally contacts the Voyager 2 again after 1 year of silence. In the billions of miles the Voyager 2 has traveled, it has taken humanity to where we will never set foot. It has flown past Uranus, Neptune, with stunning pictures and a trove of knowledge we would never have got through any other means. The trip to Neptune to this day is the only close encounter humanity has ever had with our solar system's 8th and last planet, as well as with Triton, the largest known object to originate in the Kuiper Belt. The discoveries from that flyby were spectacular, as a number of fantastic features were discovered. Neptune's ring system, a number of small inner moons, and a series of features on Triton, including cryovolcanoes and varied terrain similar to what we'd discover some 26 years later when New Horizons flew past Pluto. However, in 2020, NASA had to make the painful and risky decision to shut down the only means of communicating with the Voyager 2. Left on its own, any error that came up could not be corrected. For example, at the end of January, the robotic probe executed a routine somersault to beam scientific data back to Earth when an error triggered a shutdown of some of its functions. Everybody was extremely worried about recovering the spacecraft, said Susan Dodd, who is the Voyager project manager at NASA's Jet Propulsion Laboratory in Pasadena, California. The missions managers on our planet know what to do when such a fault occurs. Although it takes about a day and a half to talk to Voyager 2 at its current distance, they sent commands to restore its normal operations. However, with no means of communication, any problem or issue is beyond the control of the managers. In addition, other necessary commands could not reach the robotic trailblazer. But why exactly did NASA make this decision? For the answer, we have to go to Australia. The Voyager 2 has only one antenna that it can talk to on Earth, and it is located in Canberra in the Down Under. This is due to the direction it was flying out of the solar system. As a result of the probe's flyby of Neptune's moon Triton in 1989, Voyager 2's trajectory steered significantly southward relative to the solar system's plane of planets, meaning Earthbound antennas in the northern hemisphere have no way of reaching it. If the antenna goes down, everything about the Voyager 2 goes down as well. It is part of the Deep Space Network, or DSN, which is how NASA and allied space agencies stay in touch with the armada of robotic spacecraft exploring everything from the Sun's corona to the regions of the Kuiper Belt beyond the orbit of Pluto. Voyager 2's twin, Voyager 1, is able to communicate with the other two stations. Communicating with the Voyager 2 is a game of patience because a round-trip message takes about 35 hours, that is 17.5 hours each way. Naturally, the communication time continues to increase the farther the spacecraft travels. The DSN is one of space exploration's most valuable assets. It comprises one station in Goldstone, California, the United States, and 2 overseas in Canberra, Australia, and Madrid. It has been in operation non-stop for 57 years. Without it, spacecraft that traveled beyond the Moon couldn't communicate with Earth. It is used not only by NASA but also by the European Space Agency and the space programs of Japan, India, and even the United Arab Emirates. Each station on Earth is outfitted with 3 34-meter antennas and 1 70-meter antenna. They switch back and forth depending on where a spacecraft is in relation to our planet, and you can see which spacecraft are talking to Earth in real time by visiting NASA's DSN Now website. DSS-43, which the Voyager 2 communicates with, is a 70-meter dish that has been operating since 1973. It was long overdue for upgrades, especially with new robotic missions headed to Mars later in the year, and even more preparing to launch to study other worlds in the months and years to come. So last year, the dish was switched off and dismantled, even though the shutdown posed a considerable risk to the geriatric Voyager 2 probe. Ms. Dodd, who heads the group that manages the Deep Space Network for NASA, was reluctant to switch off the dish, but it had to be done. Frankly, there's never a good time to take down an asset and never a good time to fix the potholes in the road. But you know you're going to do the work at the airport not during the Christmas rush. You're going to do it when it's less busy. The risk of shutting down the line of communication with the Voyager 2 is heightened by the fact that it's a geriatric spacecraft. One risk was keeping Voyager 2's communication antenna pointed at Earth. To do this, the probe fires its thrusters more than a dozen times a day to stay oriented. However, without communicating with the spacecraft, the mission's managers had to trust that the automation on board would be executed relatively flawlessly for nearly a year. Keeping the temperature warm enough was another headache. The Voyager team had been slowly shutting off instruments in order to use their heaters to keep the spacecraft's fuel lines at 32 degrees Fahrenheit. There was, however, a way to get data from the Voyager 2 even though it couldn't receive any signal. The team would still be listening to the spacecraft. By combining the power of the other antennas in Canberra, they will be able to collect its scientific observations. The upgrade work on the DSS-43, however, was complicated by the pandemic. Ordinarily, the mission's managers at NASA's Jet Propulsion Laboratory in California would have deployed about 30 professionals to handle the dish's maintenance, but the COVID restrictions reduced the team to only 4 members, many orders of magnitude less than the amount of manpower needed. And at the Canberra station site, the logistics were overwhelming. The crew working on the upgrade had to be divided into 3 smaller teams to make sure there was always a backup team in case anybody got sick, and the whole team had to isolate and get tested. They also split the teams into morning and evening shifts to ensure social distancing. As part of the refurb, DSS-43 got 2 new antennas, upgraded heating and cooling equipment, power supply equipment, and other electronics to support the new transmitters. By October, the team working on the DSS-43 was ready to send a test message. By that time, the antenna was mostly reassembled. A device on board called the Command Loss Timer is used to help the spacecraft determine whether it's lost contact with Earth and should protect itself by going into a form of electronic slumber. The October test reset the timer and successfully told the spacecraft to continue operating. As you could imagine, there was a great sigh of relief in Canberra when the Voyager 2 responded as expected. Ms. Dodd, quoted earlier, praised the team. The DSN folks in Canberra did a remarkable job under the pandemic conditions just to upgrade DSS-43. I've got 100% confidence in that antenna that it'll operate just fine for a few more decades, long past when the Voyagers are done. Of course, both Voyagers won't work forever. While they hold the records for the farthest a spacecraft has ever traveled and for the longest operating mission, they will eventually stop working. The thermoelectric generator that uses plutonium to produce the power on board is not infinite and will give out at a point. The signs are showing already as each year the spacecraft produces 4 fewer watts of heat. Scientists believe the 2 Voyager missions will come to an end within another decade, but to postpone the eventuality as much as possible, NASA has been switching off the systems that are not in use. Only sensors that can take measurements at the location the spacecraft is are allowed to run. For example, there is nothing more for the camera to see anymore, so it is turned off. However, more drastic steps are needed to keep the spacecraft working for as long as possible. For example, Ms. Dodd and her colleagues are preparing to switch off the heater for one of its scientific sensors, the Low-Energy Charged Particle Instrument. Doing so will ensure that the spacecraft's limited power supply can keep its other systems, particularly its communications antenna, warm enough to function. She thinks the step will reduce the quality and quantity of the spacecraft's output, but the sacrifice is necessary to increase the mission's lifespan. Ms. Dodd hopes the spacecraft could reach its 50th anniversary in 2027, even if not all of the instruments will still be operating. However, as long as the Voyager 2 remains functional, even at incredibly low and inefficient power levels, we can continue to upgrade and enlarge the antennae that are a part of NASA's Deep Space Network to continue to conduct science with them. As long as these spacecraft remain operational in some capacity, simply continuing to upgrade our facilities here on Earth will enable the mission managers to gather data for years to come. Voyager 1 and 2 are already the most distant operational spacecraft ever launched from Earth and continue to set new records each day as they speed away at more than 34,000 miles per hour. They've both passed the heliopause and entered interstellar space, probing different celestial hemispheres as they go.